everyone. So today we'll be looking at this problem, longest consecutive sequence. I really like this problem. It was quite an interesting problem and I learned a lot from it. Unfortunately, I had to look it up to get a solution, but after having found a solution, I really liked the way this problem has been set and the solution. All right, so let's get into the problem. So given an unsorted array of integers nums, return the length of the longest consecutive element sequence over here. Okay, so consider this example over here. We have nums array. It is unsorted and we need to return the longest consecutive sequence. So basically a sequence means 1 followed by 2 followed by 3 and so on. Okay, so over here if you see this array, we can immediately look at the numbers 1, it is followed by 2, then 3 and 4. So we have this, which is this longest sequence, 1, 2, 3 and 4, consecutive sequence. Similarly over here, 100 is also a sequence of length 1 and we have 200. Okay, now let us consider this example over here. So we have an unsorted array here. So I think the smallest number is 0 followed by 1, then 2, we have 3, 4, 5, 6, 7 and 8. Okay, so the sequence starts from 0 and it ends on 8. So the length is 9. We also have a repeated 0 over here. Okay, so basically we need to find the length of the longest sequence. Okay, so one thing that we can do is we can sort this numbers array. But then what happens if we have repeated numbers? Over here, for example, 0 and 0. There can be like 5 repeated zeros over here. Then how we would identify whether this is a sequence or not? Because we'll have to go and see whether they are equal or not. If they are equal, then we'll have to consider the next element in the array. The looping would become quite difficult, or maybe we'll have to loop it multiple times. Okay. So the solution over here is that we need to have some reference, kind of reference of this entire array. And then we should be easily be able to look up in that reference and check whether any number does it have a number before it. So for example, if we have to check this for 100, does 100 have 99? If no, that means that this can be a possible candidate to start a sequence. Okay, so basically a lookup, a reference, we can say over here in this situation. And let me write the solution so that I'll be able to explain it clearly. Okay, and the only way to have some kind of lookup is we should not have something, we cannot have, it is not useful to have an object over here which keys and values, or we cannot, should not have a map. So the another data structure that is available to us is set. Okay, so we can have a reference set, we'll call it source, and we can initialize it directly over here like this with new set and pass in the array, nums array to it. Now if we have to look up some number in this set, we can directly uh, use the functions or the methods available to on this set. Okay, so now what we need to do is we need to traverse this array. After having initialized this set, we need to traverse this array. Okay, and we need to find all the possible candidates who can be a sequence over here. Okay, so what we do is we need to check. We go to this element first, 100, and we check whether 99 is present in this set. If it is present, that means 99 and 100 are a sequence. So 100 cannot be a start of a sequence. Okay, so if we consider this 99 is not present, so 100 is a sequence. It can be a start of a sequence. So we'll have to start looking for 101. Does 101 exist in this array? So we can check this using this source set. No, 101 doesn't exist. That means the sequence length is 1 over here for 100. Okay. Then we move to the next element, which is 4. Does 3 exist in the source array in this set? Yes, it exists. That means it is not a start of a sequence. So we move next. Does 199 exist in this sequence, in this set? No, it doesn't exist. So 200 is a start of a new sequence. Does 201 exist in the set? No, it doesn't exist. So the longest length of this sequence formed by 200 is 1. Then we come to 1. Does 0 exist in this set? No, it doesn't exist. So we can start with 1. Then we'll check for 2. 1 plus 1, 2. Does 2 exist in the set? Yes, it exists. So 1 and 2, they form a sequence. Then we check for the next element after 2, which is 3. Does 3 exist in the set? Yes, it exists. So the length increases, the length of the sequence becomes 1, 2, 3, which is 3. Now we check for the next element. Does 4 exist in this set? Yes, it exists. Okay. So the next new length is 4. Now we check for 5. Does 5 exist in the length? No. So the length of the sequence starting from 1 is 4. Okay. Then we check for 3 and then we check for 2 and then we output the longest sequence that we have found, the maximum sequence that we have found while traversing this entire array. Okay. So let me write the code for this. So we say for let I equal to 0, I less than nums dot length I plus plus. Now we should, before that, let us store the longest variable over here, which will store the longest sequence that we have found while traversing this for loop. Okay, and we will have to return longest over here. All right. Now we need to check if we need to find out a possible candidate for sequence. So what we need to do is we need to check whether the number, current number minus 1, is it present in the set? We consider it as a candidate to start a sequence only if that minus 1 number is not present. So over here, if 99 is present in the set, then it would not be a sequence. If 99 is not present in the set only, then we have to consider it as a sequence. So we say if not of source dot has this number. Okay, I'm still considering this example of this array. Okay, so what we are saying is that when we start with 100 over here, does 99 exist in the set? No, it doesn't exist. Okay, then 100 can be considered as a start of a sequence. All right. Okay. Yes. So now we need to say that let sequence equal to nums of I over here. So that is the start of a sequence. Okay. And what we need to do is we need to loop through. We need to start looping through the next numbers immediately. So now 100 is present in the uh, array. We need to look whether 101 is present in the array. Then we need to look whether 102 is present in the array. And we need to keep a count, keep a track of these numbers, and we need to keep a count of the longest sequence. So we can say let count equal to 0 initially. So while the source or our set has this sequence, what we need to do is we need to say count plus plus. That means we increase the count by 1 and we need to say sequence plus equal to 1. Okay. So what we have done is we found out that okay 100 is a possible candidate and there can be a sequence that can happen starting from 100. Okay. Then we come over here and we say does 101 exist in the sequence? If yes, then increment the count and increment the sequence. Does 102 exist in this set? Yes, it exists. So we increment the count. And after we have looped through this, what we need to do is we need to check whether we have got the maximum length sequence. So we say not count over here. Okay. And then we return the longest. So let us run this and see. All right, the test cases have been accepted. Let us submit this. Okay, so we have got an acceptance, although it is taking us a lot of time, but which is fine. This is quite, this was an interesting problem and I learned a lot, reading about it and finding a solution. Unfortunately, I could not find a solution myself.